Well, welcome everyone. Thank you for joining us. Today I think we're going to have a really interesting, well, this afternoon I think we're going to have an interesting set of talks. And I think everyone might be fed up or overhearing ASF, but I think it's still important for us to understand where the future lies for ASF research here in the US. And so I've got two guests, and you'll hear from me being third speaker. Oh, sorry, my name is Declan Schroeder. I'm a university associate. And so the focus for me is about saying, well, research in ASF here in the US is more than just what you've heard about in Plum Island's research or in Kansas. And so I also wanted to go north of the border and introduce some of the research that's going on in Canada, and then we followed up with some research going on in Nebraska. So today, again, the theme is about ASF, hopefully something different in terms of what you've heard in the past. But there's really new ways of looking at ASF, new directions, and this hopefully will feed through into the way we work on ASF here in North America. So without further ado, I'd like to introduce you to Kalhari. I'm going to avoid saying her surname. She warned me. She's from CFIA, and I think she has a slide or two to introduce herself to also. Thank you for being here.
Thank you, Declan. Can everyone hear me well? So, thank you, Declan, for inviting me to this Leman conference this year. So, originally, my boss, Dr. Arun, you may have heard of the ASF research and OIE activities in our region. He is the expert in Canada for ASF and CSF. So he was supposed to come, but unfortunately he couldn't. So I'm here with our research work. It's a work that we've been doing for the past few years, mainly in identifying better surveillance tools for the early detection of ASF. So I'm from Canadian Food Inspection Agency, National Center for Foreign Animal Disease in Winnipeg, Canada. We are the only lab in Canada that can handle level 3 and 4 pathogens, and especially when it comes to animal experimental level of that risk group. So we're pretty special, and I'm here to give you a brief overview about our work at the lab. So CFIA is the regulatory agency for food safety and animal health in Canada. We have a network of 13 reference and research labs across Canada, and NCFAD, where I come from in Winnipeg, is our national reference laboratory for foreign and emerging animal diseases. And we're located together with the Public Health Agency of Canada, where the national lab is, and that's like the umbrella of One Health. So we deal with prevention, detection, control, and reporting of foreign animal diseases, zoonotic infections, and emerging diseases in Canada. And we have, like I said, CO3, CO3 Act, CO4 labs, as well as CO2 labs. We are a BOA reference lab for African swine fever as recently in 2022, and then classical swine fever, high fat and low fat AI, and foot and mouth disease. So Dr. Arun, who is our PI or the unit head, is the expert for ASF and CSF in Canada. And we are also a reference center under FAO for foot and mouth disease and zoonotic and emerging pathogens. So our structure, basically, we are a big lab comprised of different units that deal with various pathogens. Avian, mammalian, which is my unit, vesicular diseases unit that mainly deals with vesicular diseases like FMD, special path unit that is our level 4 pathogen unit, pox virus unit. We also have a serology group that does all the CO2 serology screening. And then we have a support group called Genomics that's helping us with our genomic detections for across the lab. We have a reagent development unit, animal care unit that helps tremendously for our animal studies that I'm sharing today. A QA unit, so we are QA, like we follow the ISO certification for lab laboratory diagnostics. And we do have this Canadian Animal Health Surveillance Network, which we call CASN Lab, so federally recognized laboratory network that runs all the tests that we run in the national level. So they help us specifically with our ASF surveillance system that we are following right now. And we act as the confirmatory laboratory and the support laboratory for them. So like I said, our units handle different viruses within each unit, like you see here, the avian unit, the vesicular unit. This is what our special pathogens unit does, and then Pox unit, and this is our unit. As you can see, mammalian diseases unit handles like 11 or 12 viruses. ASF, CSF being very important diseases in our diagnostic workflow. So we offer diagnostic services to the country, as well as we do research because we have the animal facility and the expertise. And we also provide OIE reference activities, supporting pretty much every region, depending on the level of funding and support. And so, getting into the economic impact, I'm pretty sure you've heard this all day. For Canada, ASF prevention is super important because we are one of the largest pork exporters in the world, and we are in the swine industry heavily, so it's super important that we prevent ASF as early as possible in our region. Why is early detection so important? So if you were here on Saturday at the workshops, I'm pretty sure you went through these slides before, but I'm repeating again and again, especially for the new attendants of the conference. If you look at this finding from a paper in 2021 about the transmissibility of African swine fever, compared to ASF, compared to CSF and FMD, you can see within 2 to 4 weeks period, spreading of African swine fever was relatively low compared to the other two diseases. So this takes us to the point that if we diagnose it early enough, there's enough time that we can definitely take control measures to stop the further spread of the virus. It's not only about detecting early enough to prevent it, we can also stop it as early as possible when you detect it. So there, laboratory diagnostics in terms of early detection is so vital. In that aspect, Canada has started our surveillance on ASF, which we call CanSpot ASF. This is an enhanced surveillance to protect the swine population, and our goal is early detection to quickly contain ASF as soon as possible. And our detection has two aspects at the moment: risk-based early detection of certain diagnostic cases when requested by a vet or a pathologist, and risk-based early detection of pendant carcasses from the abattoirs. These are all done on the federal level by our laboratory. Testing conducted by the CFIA, which is our central lab, as well as the CASN laboratories. So here, what I would like to mention is these detections are mostly based on tissue samples that are recommended by law. And also, Canada is pretty high on their awareness programs. There's education of the producers and the public. Social media-based education is happening everywhere at the moment. So why do we need better surveillance tools? Like I said, ASF, if you, veterinary point of view, you cannot differentiate it from most of the other differentials by the naked eye. On Saturday, we had a nice exercise that we were trying to identify ASF versus PRRS. If you participated in it, you would know it's impossible. So it's very important that we perform laboratory diagnostics, and BOA recommends mainly individual sample types, such as whole blood, lymph nodes, spleen, tonsils, for molecular level diagnostics, and serum for serological diagnostics. These are great, and that is available, but they are labor intensive to collect, expensive, and pretty much impractical when it comes to large-scale commercial level. So in terms of surveillance and our great situations where you have to screen large numbers of animals, it's it's pretty important that we find other alternative sample types that give us efficacy as well as ease of sample collection, less animal handling. It should be industry feasible as well, and also collectively represent herd health and give us that sensitivity and specificity in the diagnostic test. So here I have categorized the alternative sample types that we have tested so far into two as group samples, such as oral fluids and processing fluids, and individual samples, such as the superficial lymph nodes, skin baths, seized meat, exudates, etc. Oral fluids. I mean, talk of the season, everyone's interested in oral fluids. It's a great sample type. It's an aggregate sample type, which comes as a mixture of saliva and oral mucosal transudate entering the buccal mucosa from the capillaries. So we easily collect it by hanging a rope and letting the pigs chew it for 30 minutes. Dr. Jeff Zimmerman always mentions as working with the pig. That's how you collect this sample. You're not working on the pig, but they're working for you. So it's widely used in the industry for the diagnosis of surveillance of several other swine pathogens. So labs are already receiving it, so we can just piggyback on it if it's a good sample type for ASF detection. So this is how we collect in our experiments. We use a Tego oral fluid kit, that's a cotton rope-based kit, and we hang our ropes on the gate, and the pigs would chew on it, and then we squeeze the rope and collect the oral fluids into the tube provided with the kit. So the first experiment that I'm sharing with you is already published. You can read it on Transboundary and Emerging Resources. This is about evaluation of oral fluids as an aggregate sample type for early detection of ASF using 4 independent studies. So we performed 2 studies at our facility using ASF Georgia highly virulent strain, and then the other 2 we performed in collaboration with Plum Island Animal Disease Center with moderate to virulent ASF mold disseminated strain. In our study, we had 25 pigs in the pen, whereas in Plum Island, they had 20 pigs in the pen. So all studies follow the same experimental design. We took 1 pig randomly out of the pen and infected that pig with the ASF virus intramuscularly, and we call him cedar pig. So this cedar pig was sent back into the pen and was just commingling. And from the day we introduced it back to the pen, we started collecting oral fluids and the other individual sample types. And we also did clinical scoring, rectal temperature collections, and we finished the study when the mortality or 50% of the pen succumbed to disease. And this was a national Pope Board funded project, so we're really thankful for this study. And we tested our samples with the regular sample processing flow followed by our SOPs with the mass extraction. And the only difference was we used real-time PCR ZAC assay that's followed by the USDA. So it's much more sensitive. And then we analyzed the data. And here, what I'm sharing is the graphs exactly from our paper. So the first, I want you to focus on the first 2 top graphs. So these are the 2 ASF Georgia studies. The top 2 graphs show the clinical manifestations in this study. And the bottom 2 graphs show the ASF genomic detections in the whole blood as well as in the oral fluids. So if you look at the first graph here, the first study, the red squares show the cedar pig's rectal temperature. So cedar pig's the one that's infected. And you can see that his temperature is getting pretty high from like day 2 on. And cedar pig dies at like 6 days to 7 days post-infection. And if you look down at the bottom 2 graphs where you can see the detection levels, the red stars it's pretty blurry, but you can see this red line. That is the oral fluid detection. And then there are yellow boxes that you can see. That is the whole blood ASF genomic detection in full blood of the cedar pig. So in the first study, or the first experiment, we saw by second day, the cedar pig was already viremic. The viremia hit really high, and he died at 6 days. And the second study, viremia started very early, second day, and then he died at 7 days. And if you look at the oral fluid detection, you can see as early as 3 days to 5 days, we can detect the genome in very low level, although by the time the cedar pig is viremic, at least within like 2 days, you're starting to detect the presence of the viral genome in oral fluids. So it is pretty early level of detection. And if you look at the other pigs' whole blood, you don't see viremia coming up in the other pigs until 8 days to 10 days. So there is still a pretty good window that you can do your, like as soon as you detect that virus in the oral fluids, you can still perform your individual sampling and find out what other animals are infected in the pen. And then in the Malta study, it was pretty similar, also a little different in terms of the timeline, because Malta is a relatively moderately virulent strain. There also, the cedar pig died at 6 days up to 10 days. So you still see that very early detection of the oral fluids in terms of detection, and then the detection continues till the end of the study. So once you start detecting the oral fluids, it will 100% detect, even though the other pigs are still not showing any viremia. So it's a quick summary table of the same observation. And the highlight was we were able to detect the ASF genome 3 to 5 days post-introduction of the infected pig, at least 2 to 3 days before that cedar pig was found dead. So before you see that first pig's death, you do detect the virus in oral fluids, and then you see a dead pig in pen, and if you suspect, you can always go back into your rest of the contact pigs and do blood work on them. So the pen prevalence was at the lowest at this earliest point of detection. So the main key here is, since there is very low viral load in the oral fluids as expected, you cannot, you have to be pretty cautious when interpreting negative oral fluid results, as you see, because having a negative result doesn't mean that there are no viremic pigs over there in the pen. So, however, in terms of early detection, I think oral fluids can be very good industry feasible and can be used in combination with other surveillance tools. And we have conducted a field evaluation in Vietnam and just finished the analysis. And it is a SHIP-funded project. I'm not sharing any data there, but I can tell you that it's looking promising, and the data looks very similar to what we saw in the controlled laboratory scale, even though there's so many other factors contributing in the field scale. Next, I'm moving on to swine processing fluids. So in swine industry, we do piglet processing, castration and tail docking, and we collect the tissue, and then you can give rise to the processing fluid based on that. And that is a very passively generated sample type. And it's already, there are literature available on how great of a sample type that is for other viruses. So we did a study based on swine processing fluids, another national board-funded project. And here it's not, we are in the process of publishing this data right now, but based on 2 studies we did on 40 pigs in each study with 2 moderately virulent ASF strains, we were able to detect the genome 3 to 4 days following the infection of individual animals. And we did pool and then saw virus, the tissues can be, 100 pigs can be pooled without losing the ability to detect ASF genome at 4 dpi. And we also detected antibodies in the processing fluid, so that's an added bonus. This is a sample type that we were kind of excited about. Individual sample type, superficial lymph nodes. So when it comes to passive surveillance, specifically investigation of dead pigs, it could be the domestic pigs, pigs found in folding pens, and also wild pigs. So dead pig surveillance has to be an important part of our surveillance network. And it's very critical for early detection. And BOA does recommend to collect lymph nodes. I know that the lymph nodes such as gastrohepatic lymph nodes, you have to perform a proper post-mortem examination that could involve lots of training of people as well as somewhat contamination of the premise. But we were looking into superficial lymph nodes such as the superficial inguinal lymph nodes you can see here. And it's pretty easy to, relatively easier to put a superficial incision and collect. Especially if the lymph nodes are enlarged, you can easily detect them. And this easily avoids site contamination, and we can train individuals easier. We did look at the detection levels in superficial inguinal lymph nodes compared to the same animal's spleen detection levels with ASF genome, and we saw a pretty positive correlation with the detection levels in spleen with 100% sensitivity and specificity. And you can read our publication on this if you're interested in. And meat exudates is another passively generated sample type. Specifically, if you don't have access to the carcass or the animals and you only have the meat products, it's something you can definitely test. The meat, the pieces can be frozen in sealable plastic bags and then thaw overnight, and it generates the meat exudate we call meat juice. We tested with, basically this is based on the diaphragm tissue, but you can also use ears cut at the base with more meat, but it takes quite a bit of space. And there's also suggestions from the audience the other day with tongue tips. So there's various tissues you can use to generate meat juice. And we did see a strong positive correlation in terms of detection levels with whole blood and meat juice, and also serum antibody levels with the meat juice antibody levels. So that paper also you can read if you're interested in, and if not, let me know, I can always pull it up for you. So in summary about our alternative sample types, that's what I have to present about the oral fluids, processing fluids, superficial inguinal lymph nodes, and meat exudates. And I will go into another, since I have a little bit of time, how am I doing? Good? 5 minutes? Okay. So the other day I showed the work we did with some portable field deployable assays in terms of point of care tests. So these are some of the portable battery-powered turbocyclers available in the market right now, and out of which we did some extensive testing with Franklin, which we call, the instrument's called BioLim. This has a syringe-based nucleic acid extraction as well. 9 samples can be tested at a time, and then 3 targets. So 27 targets in total, and takes less than 60 minutes. So these are some of the specs. And you also work with the database, so it can be the results can be uploaded, and you can do real-time monitoring. So what we did was we transferred our CFIA and CFIA pignon assay successfully as a duplex assay with beta-actin without losing any sensitivity or specificity. So the study was based on how our assay, the M1 extraction plus Franklin, which comes with the instrument, how much it was correlating with the MagMax extraction and our CFX96-based real-time PCR. So there was a very highly positive correlation. And it was also tested in Vietnam at 7 ASF suspected farms and identified as a highly sensitive and specific assay. So yeah, that is one success story, and the publication can be read again. And there are other methods like the LAMP assay, CRISPR-based systems, still kind of in the process of early development. So portable field deployable assays are great, highly sensitive and specific. However, the instrument cost will be pretty high, so it's like a huge investment. But great for great investigations, on-site testing. There are various newer developments with that. And then touching base with the antibody-based lateral flow assays. These are cheaper, easier, and quicker, highly specific, but could be less sensitive. So that's one drawback. And our study was mostly based on the pen check assay. What we found through this work was that the limit of detection was pretty high, so you have to have a very low CT value, as low as 23 CT, in order to detect. But that being said, it detects 100% specificity at the peak of acute clinical disease. And yeah, and we also detected ASF not only in blood but from tissues as well. So it can be used at third level for screening, but not for individual animal testing, as not as good as real-time PCR. Yeah, and the other challenges with it is the sensitivity. Mainly the sensitivity is only during the clinical phase. And in wild boars, clotting and decaying can outweigh the benefits of high viral loads, even if there is high viral loads. So in summary, that's what I have to, what our take on these point-of-care tests. Yeah, with that, I'm going to conclude. Lots of huge thank you to all our funding agencies, especially CFIA internal funding, USDA support. National Folk Board and SHAKE have been our biggest funders so far. And Dr. Aruna Abdullah and our entire team, all the collaborators listed here. And during the past few years, our team has been changing a lot, but these are the people who are working very hard every day to get this data out. Yeah, with that, let me know if you have any questions, and I'll be around tomorrow as well.
Do we have any questions? I'm sure we can do a couple. I've got a question, just in case you can't hear me. Oh, thank you for that. So I've got a question regarding transport of samples from the field to the lab. Have you done any tests to see whether the oral fluids would be stable enough, and when you get it to the lab, would that give you the same results?
Right, we haven't directly done a test on transportation. For that you would have to take a sample from the field when you collect it and then freeze it and then come back. We haven't done anything directly like that, but our study in Vietnam would be the closest representation of that, because the samples were collected on farm and then had to be transported to the lab in order to get aliquoted and then stored, and then we tested them later. So otherwise, no, we haven't done any direct testing on the effect of transport.
So those samples in Vietnam, were they pretty stable now?
Yes, they were. And they exactly followed the pattern that we saw in our laboratory level detection. So, yeah. As long as you freeze or keep on ice, that would be the best way to preserve.
Thank you.
Sarah Meister with Pigsty. See you again. Thanks. This was a great presentation. We talked a little bit in the hall after the other presentation that you did, and this is just a question I'm trying to get my head wrapped around. So you're working with pigs with African swine fever virus. Is it all in that facility that I think you showed a picture even at the beginning? because you have to obviously have a high level of security
Yes.
wrapped around this. I can see working in a lab, but this was,
Yeah, so the
this
way,
is working with pigs.
right, so the way our facility is built is that just like the other level 3 and 4 laboratories or the animal facilities in the US and rest of the world, we have laboratories that people work for laboratory tests. And then we have an animal facility with animal cubicles that are under negative pressure with bio-sealed doors. You walk in, you shower out. We have a high level of bio-containment in those animal cubicles. So yeah, and when you it's made in a box we call it box in a box design. So your highest contained things are in the middle of the box, and then there is another layer and another layer. So in each layer in your middlemost containment, which is your CO3, CO3 plus or 4, those cubicles have the lowest air pressure, so that it contains the viruses and everything within them. And the more you go into higher and higher containment, the pressure drops more. Yeah, and that's how you contain. So you bring in clean pigs, you infect them, you work with them, and once they're done, you euthanize them. They go through a rendering process in order to get out of the facility, and then that's how you ensure that the viruses are killed, and then that you use all these indicator organisms to identify whether the rendering and the autoclaving went properly. So it's a whole process of managing CL3 and 3 plus CL4 facility. Just like Plum Island, just like Fulbright Institute, FLI, and CFIA in Canada is the same.
Very good. Thanks very much.
Thank you.